Assalamualaikum and hi everyone. Welcome back to Applied Statistics course video. My name is Ku Muhammad Naim. I'm going to cover chapter 1.3, review on descriptive statistics. Right. So by the end of this topic, you should be able to summarize the data using measures of central tendency, such as mean, median, mode, and mid-range. You need to know how to describe the data using measures of variation. We have range, variance, standard deviation, and coefficient of variation. You need to know how to identify the position of a data value in a data set using measures of position such as quartile, decile, and percentile. Okay, review on descriptive statistics. So typically, it is used to confirm the conjecture about the data, to confirm the assumption about the data set. So actually we can summarize our data by using measures of central tendency, measures of variation, and measures of position. Alright, some of these measures are present as traditional statistics. Okay, if the measurement described regarding the population data set, so we are going to call it as a parameter. So if the measurement described about sample data sets, we're going to call it as statistics. Okay, so we go to the first one, which is measures of central tendency. So measures of central tendency, sometimes we call it as measures of average. There are four types of measures of central tendency. We have mean, median, mode, and mid-range. So for the first three, which are mean, median, and mode, we can use these first three to describe the shape of distribution of our data set. Alright, so the measures of central tendency are used to describe the entire set of our data set or observation with a single value to present the central value or middle value of our data set. Okay, we go to the first one, which is mid-range. Mid-range is a rough estimate of the middle. So here is the formula for mid-range: the lowest value plus highest value and then divide by 2. Okay, what you need to do, you get the lowest value, you get the highest value, sum up both of them, and then we divide by 2. Okay, so there is an example here. Okay, one of the important property of mid-range is it can easily affected by extremely high or extremely low value, which is known as outlier. Alright. Okay, we go to mean. Mean is the sum of the values divided by the total number of values. So if your data is taken by the population, so you're going to calculate the mean based on the population mean. So you're going to use this formula with the correct notation, which is mu, right? And if your data is taken from the sample, so you're going to use this kind of formula. Okay, alright, we go to the next one, which is median. Median is the middle number of n ordered data, which is ordered we refer to the range data from the smallest one to the highest one. Okay, so we have to make sure before we calculate or before we get the median data set, a median value, we need to rearrange our data from the smallest one to the largest one. Okay, if your n or sample data is in odd counting numbers, so you're going to use this kind of formula to get your median, to find out the position actually. So median, one more thing, median is location based center value. Okay, we need to find out the center value of the ordered data set representation. Okay, if n is even numbers or even counting numbers, so you're going to use this kind of formula, right? A simple formula. Okay, we go to the example here. The first one, we have 1, 2, 3, 4, 5 data set, and then you don't have to calculate, just do rearrange and then get the center one, which is 5 here. So 5 is our median, so the third value. Okay, for the second one, we have 6 data sets, so the center one is between 5 and 6. So get the summation of 5 and 7 in from our data set, and then divide by 2, so we got 6. Okay. Alright, we go to the next one, which is mode. Mode is the most commonly occurring value in our data set or our data series. The most frequent data occur in our data. Okay, look at the example. There are 3 conditions or situation that we can get to find the mode. The first one, 163785. Here we don't have any mode. Mode is not exist. For B, 1637835, there are 2 times 3. There are 2 times 3 is coming out here. So our mode here is 3. So the next one, now we have 2 times 4, 3 and 7. So our mode here are 3 and 7. So we can have more than one mode, okay? Or mode may not exist for data set. Okay, and then for mode, one of the properties that we need to consider here is the mode can be used when the data are nominal. Alright, so as I mentioned previously, we can identify the shape of data distribution by considering these 3 center of a measure of central tendency from mean, median, and mode. If your mean value equal to median value equal to mode value, so your shape of data distribution represent symmetric, which means the right side and the left side are balanced. Okay, you can see here. Okay, if your mean is greater than median, which is greater than mode, so it represent positively skewed or right skewed. Okay, if your mean value is lesser than median, which is lesser than the mode, so your shape of data distribution represent negatively skewed or left skewed, right? Okay, in reality, if you can see the notes down there, median can be greater than mode or mean value. All right. Okay, the shape of the distribution may be identified by observing the position of the mode value. So you can see the main thing is you refer to the mode value. Okay, you may do this example here, right? Okay, there are some properties of mean and median. Okay, so you need to understand this mean and median representation, and then when to use mean, when to use median. All right. Okay, the first one, the mean is unique and not necessarily one of the data value. The mean is affected by extremely high or low value, easily affected by outliers. That what can we say? If this occur, the mean may not be appropriate average to use. Okay, the mean is used in computing other statistics such as variance. Okay, the mean cannot be computed for an open-ended frequency distribution. If you have a data in open-ended data set, so we cannot calculate or compute for that kind of value. The mean varies less than the median or mode when the sample are taken from the same population and all 3 measures are computed for this sample. And the last one, the mean is not appropriate average to use if the shape of distribution is skewed. So I think this one is very informative that you can think or you can see from your data set. Okay, it is not appropriate average to be used if the shape of distribution is skewed. So the mean is a good measure of central tendency if your data shape represent symmetric. Okay, we go to the next one. The median is used when one must find the center of the middle value of a data set. Okay, so median is a location-based center value. Okay, the median will make sure that the data values fall into the upper half and lower half of the distribution. For example, if we do have 100 data set, so the first 50 and the next 50 are balanced. Okay, the median is affected less than the mean by extremely high or extremely low values. So this is the the goodness of the median compared to mean, less affected by outliers. Okay, we go to second measure, which is measures of variation or measures of dispersion. Okay, measures of variation or measures of dispersion are measures that determine the spread of data value, which includes the range, variance, standard deviation, and the coefficient of variation. Alright. Okay, if you look at the variance, standard deviation, and coefficient, these are more meaningful and popular measures to describe the variability of the data. Okay, this measure can help researchers to describe the data more accurately. The variance and standard deviation are used quite often in inference statistics. Okay, we go to the first one, which is range. Range is the difference between the highest value and the lowest value in data set. So you just find out the highest value and the lowest value and then get the difference between them. So you're going to get range. Okay, so one of the important properties of range is it is easily affected by extremely high or extremely low data set, which is known as the outlier. Very simple. Okay, we move to variance. Variance is the average of the squares of the distance each value is from the means. So if our data is taken from the population, so we are going to use this formula to get the population variance. So look at the notation here, and don't forget about the notation for the population here. Alright, if your data is taken from sample, so you're going to use this formula with the correct notation, variance for sample. Alright, standard deviation is the square roots of the variance. Alright, so you need to get the variance first, and then you just square root your variance data, and then you're going to get the standard deviation. Alright, for this kind of properties, we need to know some descriptions of variance and standard deviation, right? Okay, the first one is the variance is the average of the square of the distance each value is from the mean. If the data value are near the mean, the variance will be smaller. This one is important. Right? If the data value are far from the means, the variance will be larger. Alright. Okay, the square distance is used since the sum of the distances will always be 0. Variance is always a positive value. This one we have to take note. Some of the students previously, when they calculate for variance, I don't know how they can get a negative value. So do take note. You have to make sure your variance value must be in positive value. And then the thing that you need to take note here is there is no unit for the result of variance. Okay, for standard deviation, it is square root of the variance. So you get your variance and then you square root that value, so you're going to get the standard deviation. It is a measure of deviation of value from the mean. Okay, the standard deviation is always positive value as well. Okay, the units of standard deviation are similar as the unit of the unit. So here, standard deviation, we do have a unit from the original data that we use, not for variance. You have to take note that. Okay, we go to the next one, which is coefficient of variation. This is new. If you use the previous model, you are not going to find out this kind of subtopics in your module, right? Okay, coefficient of variation is the standard deviation divided by the mean. Okay, again, this is formula for population coefficient of variation. This is formula for sample of coefficient of variation. The difference is we refer to the notation here. Alright, coefficient of variation refer to the relative representation techniques result. Okay, so you're going to get in percentage result. Okay, we convert from the specific unit or particular unit to the percentage unit. Okay, the properties of coefficient of variation here, the result is expressed in percentage, right? So you have to take note, you are going to put percentage unit. Okay, the parameter or statistics, okay, that allow user to compare the standard deviation when the units are different. So this is one of the good things or the advantage of the coefficient of variation. When you're going to compare with the two different data set, with a different unit, so you're going to use coefficient of variation. If you use two different data set, okay, with the same unit, you can use variance or standard deviation. So now when we have two different data set with a different unit, so we are going to use coefficient of variation to see the measure of variability or measure of dispersion. So we convert from those two units into the percentage unit. Okay. Alright, so this is an example for coefficient of variation. Not coefficient of variation only. You can get a range here. We have a variance, how to calculate variance from this value, and then the variance and standard deviation from if data are taken from population. This one, the sample, and then coefficient of variation. Okay, why we need measures of variation? Okay, these measures of variation can be a judgment about how well the measures of average or measures of central tendency illustrate or depict, show the data. Right? Sometimes it is called the measures of variation because it can measure the variability that exists in the data set. So this is why we need the measures of variation. Sometimes the measures of central tendency cannot work very well. So to see the variability of the data set, so we use measures of variation. Alright, it can be used when the measure of central tendency do not give any significant meaning or not needed. Right? Okay, so we look at this example. Suppose we wish to compare the performance of two groups of students in a test. Given the mean values are the same, which means when we calculate the mean for these two groups, we are going to get same values, right, for both data sets. In short, you might conclude that these two groups of students are equally well performed in the test because we got the same values. However, in the data set, examined graphically as shown in this figure below, a different conclusion might be drawn. So when you look at this kind of figure, you can see the distribution of marks from group A and group B. Right? The smallest value for group A is 30, the highest one is 90. The smallest value for group B is 50, the highest value is 85. So actually from this figure we can see the distribution very well. Okay, so if you refer to this yellow box here, the both groups have the same total of students. We have 6 of them. Students are given the same set of tests, and the means of score is calculated as 66.67 marks for each group of students. You may do calculate by your own. You can see the mean value are 66.7 for both data set. The mean value are same, but the spread of variation of test score is quite different. Right? This is what we need to find out here. Right? Even we have the same mean value, but you can see the spread of variation. The test score is quite different. So I'm going to share with you how to get the spread from this one. So this is our distribution that we can see here. Alright. Oops, sorry. Alright, something like this. Alright, so the spread is referred to what? This one, for example, is referred to mode. Alright. So this is represent the spread of the data. Alright, so if you have a spreader one, okay, so your data will be more dispersed. That is what we can say. So from group A and group B, we can see group A has more variability compared to group B. Group B is quite more consistent, right? The spread is smaller compared to group A. Okay, so we can do conclude that the test score for student from group B is more consistent and less variable, or instead of that. Okay, when the mean value are equal, the larger the data range, the more the variable of the data. Alright, so to compare two data sets, right? Okay, you may do use some statements, standard statements, to answer the question or to interpret your result, like this one. Sometimes you can say our population 1 is less dispersed, less spread, less variable, more consistent, more precise, accurate, or better data. And then for population 2, more dispersed, more spread, variable, less consistent, less precise, less accurate, or worse data, right? Okay, we go to this example 1.7. The following data represent the age of lecturer in 2 faculties at UNP. So we have 2 data set here with the same unit, right? In year, age in years, right? From FEES data, FKEE. For this sample data, our data refer to sample. Find the standard deviation, then identify the which data set is more consistent and less dispersed. What can you say about the variation of age for lecturer in both faculties? Right, so we can do calculate our standard deviation, maybe directly from our calculator. Okay, so we are going to take the standard deviation value here. Standard deviation for FEES is 7.4670 years, FKE 9.9460 years. Right, do take note, do pick the correct one. Our data will refer to sample, so take the standard deviation for sample. Okay, so from here, to say about the variation, so we can compare with standard deviation if we do have a data set with the same units here. So we compare here, our standard deviation for FEES is lesser than FKE. So we can say that FEES data is more consistent and less dispersed. Alright. Okay, now we go to, okay, you may try this exercise at your home. There are answers there. Okay, once we do have 2 different set of unit or variables, how to see how to compare both of them. Alright, if the 2 samples do not have the sample unit of measurement or the variable are different, so the variance and standard deviation for each sample cannot be compared directly. Alright, so this is what you need to know. We cannot use measurement for variance or standard deviation to see the variability of your data between 2 datasets if these 2 datasets have different units. Right, example, suppose a car dealer wants to compare the variation between number of sales of car and the commission. Right, so see, we have 2 different variables. Okay. Right, the best way to compare the variability within these 2 variables is by using the coefficient of variation. So these are what I've covered from the previous slide, which is this one. Right, coefficient of variation is the standard deviation divided by mean. So this is the formula for population variation, formula for sample variation. Get your standard deviation value, get your mean, and then convert into percentage. Right, it means that if your coefficient variance for the first group is lesser than the second one, so we can say that the variable 1 or group 1 is less variable than the variable 2 or less dispersed compared to variable 2 or group 2. Okay, now we go to 1.3.2.1, accuracy and precision concept, which cover for validity and reliability of our dataset. Okay, the concept of this accuracy and precision are very important to make sure or to ensure that our data collected from experiment that we handle or observation is good or valid and reliable. Okay, accuracy is referred to how close a measured value to the true measurement. So you're looking for the center one, for example, and then how accurate your data distribution towards that kind of center one or the true measurement. No measurement or device is perfect. That what we can say. Okay, it can easily be inaccurate or lead to false of measurement. This is a real data set. There is still a tolerance for error. Okay, accuracy must be accounted for in your result. The bigger the difference between the measure and the true values, the less accurate or less valid the measurement. So in seeking the accurate data, so most of the data are on that true measurement. Okay, precision is how close the measured value to each other, right? It is not focused on the true measurement actually, just focus on the other data set that you have together, and how consistent your results are for the same phenomena over several measurements. Okay, precision as a measures of variation must be accounted in your calculation and result. The precision of a measurement is the size of unit used to make a measurement. So the smaller the unit, the more precise or more reliable the measurement. Okay, you can see the game of dots here from this kind of table that it used to illustrate the accuracy and precision of your measurement. So if you can see from picture A, right, the distribution of the data here, right, very accurate, close to the mark, which is the true measurement, okay, but not very precise. All right, since the dots are spread out everywhere, not spread out too much, though I mean the distribution or the variations for all of the marks are not too far, so we can say the distribution from picture A are valid but not reliable. Okay, we go to the picture B. We can say the distribution is quite precise, right? The precision without accuracy, right? We do have the precision each of data are on that one part, you can see that, but it is not accurate, right? The close to mark, not close to mark, right? Okay, so it's very consistent but not near to the mark, not valid but reliable. Okay, we go to the next picture, picture C. Oh, it is not accurate, inaccurate and imprecise. So you can see the distribution of the marks are everywhere, not valid and not reliable. So we go to the last picture. This is what we want, what we are looking for normally, but in reality we cannot get this kind of data set. For example, the tabulan, your distribution is good as this one. This data or this mark is accurate and precise, right? Valid and reliable, very good for measurement. Okay, so I think that's all for my part. Thanks for watching and good luck. Assalamualaikum and bye bye.